is very much an obvious part of our lives that we see whenever a child is born is that we are the products of cells that have been growing and dividing, sometimes combining together, for hundreds of millions of years. I'll say that again. Hundreds of millions of years, if not billions.
Our germline cells.
Our germline cells. Now, that should tell you right away that there's nothing about the propagation of life that inherently leads to its damage. That is to say, it is perfectly possible for cell lineages such as those that maintain life, that maintain our species and its ancestral species for hundreds of millions of years. Biological processes can maintain life indefinitely. There's nothing about the biochemistry of life that requires its cessation. Now, if I were a member of the Immortality Institute, I would say, man, that's great news.
It is. Would seem to be.
Yeah, I think so. But there's a further point which some of your listeners may not know, but which to a biologist like myself is huge. And that is that we know that there are individual animals and plants and vastly more single-celled organisms that can go on living without dying unless something bad happens to them, like an infection, or they get stepped on, or the temperature gets really weird. So there are lots of living multicellular animals that we know can go on living very happily without accumulating damage. So it's not just that individual cell lines can go on forever, which tells us there's nothing about cell biology that requires accumulating damage.
Right.
We even know that there are entire multicellular animals that can go on living and dividing and so on and so on without any sign of aging at all.
Right. I'm familiar with such as the bristlecone pine, is brought up often as something that continues on for thousands of years, and that rockfish and perhaps tortoises can continue.
Well, I'm actually not referring to those cases.
You are?
I'm not. Though they are, I think they are reasonable evidence for how slow aging can be.
Okay.
But I'm talking about cases where scientists in laboratories have maintained animals right in front of their eyes.
What are we talking about here? Hydra?
Hydra being the best researched example, but there are other small, what we call fissile, meaning dividing into invertebrates. I'm very fond of fissile sea anemones because I think they're really cute looking. There are lots of others. So there is nothing fundamental about cell biology or even the biology of entire animals and plants that really requires aging.
Okay. And what you said just brings one question into my mind immediately, is that I don't think that we're aware of any mammals or warm-blooded animals that have that capability. And do you, if I'm correct, and I mean I haven't heard of any mammals that have zero aging throughout their life, then is there something about being warm-blooded or being a mammal that necessarily precludes being able to evolve, or being able to live indefinitely with no damage?
Well, it turns out we know. I mean, remember, we started off with the example of our own. You and I are only alive right now because cell lineages propagating for hundreds of millions of years eventually led to us.
Yeah, I would say.
Now, so there's nothing. So Justin.
Yeah.
There's nothing about the mammalian cell that stops our life being sustained indefinitely. Now, you did raise, however, the really key question: what separates situations in which evolution does in fact produce an immortal lineage, whether of whole animals or cells, but the situations where it really does not?
Right.
That's the key question, right?
Mm-hmm.
And evolutionary biologists basically solved that question between 1941 and 1980. And the shorthand verbal statement of this work, much of which is very mathematical, is to say that the force of natural selection falls with adult age in organisms that reproduce by producing an egg or something like it, which all mammals do.
Right.
There are no mammals that can reproduce by splitting in two or somehow fragmenting and generating those fragments of new animals. So, unlike Hydra, for example, unlike Physalia anemones. So, in fact, evolutionary theory predicts that all mammals will show aging, because all mammals have that type of reproduction where the adults don't fragment, but instead produce tiny little, eggs and sperm, which combine to form a zygote and produce an organism. So, I wanted to start with a general principle, which, if I were a fan of the Immortality Institute,
sure,
I would regard as really great news. But there's nothing about life, not even about the cells that make up, the germlines of mammalian life, that requires aging. It's instead specifically due to circumstances in which the force of natural selection falls with age. And unfortunately, that is us. But my whole career as an experimentalist since the 1970s has been based on actually manipulating that force of natural selection in the laboratory to see, well, I did that for several reasons. One was to test this basic idea. And it turns out, experimentally, this is probably the best idea in all of the biology of aging. Nobody has to make ingenious, charismatic, persuasive, verbal arguments about the validity of the evolutionary theory. It is derived mathematically from first principles, and it is corroborated in the laboratories of scientists around the world, easily. There's no real scientific controversy about it, except in the sense that people who don't understand it and get all confused about it.
Right.
Just like Einstein's theory of relativity, which is widely misunderstood. So this is a rock solid piece of science. Now, I don't expect your listeners to be the least bit interested in how excited evolutionary biologists are about their theories. Instead, I think they should also be excited about the fact that we have been able to use the force of natural selection to manipulate aging, specifically in ways whereby we substantially increase lifespan. And we do so by a very different method than caloric restriction. You can significantly increase your lifespan if you're a rodent and you undergo severe caloric restriction.
Yeah.
But when you do that, you greatly curtail your fertility and a number of other functions. And similarly, the mutants that are known, particularly nematodes, but also can be found in Drosophila, that also extend lifespan substantially, like caloric restriction, do so with a lot of bad side effects.
Yeah, I've seen the ones with low IGF, insulin growth factors, live longer, but then they turn out to be dwarfs as well.
You get dwarfism, you get infertility,
sure,
you get lack of disease resistance.
Right.
Ray Wolford, the great
CR researcher. Yep.
Great CR researcher, I knew, wonderful human being. Did the Biosphere 2 experiment, where he did a really good human caloric restriction experiment, and when those people walked out of Biosphere 2 after 2 years, all of them, except for Roy, they headed off for fast food restaurants to, get calories. And, the same thing with any fruit fly or nematode or mouse or rat that's put in a caloric restriction protocol. Give them the choice, hey, they'll eat food. And that's because for most animals, not the Wolfords, Roy or his daughter, caloric restriction makes them miserable. They want to get away from it.
Yes.
And the lack of success.
Included.
All right, so we're being honest about this.
Yeah.